Hi everyone and welcome back to Activity 35. Today we are going to talk about how we can use matrices to find the area of a triangle and other polygons. When we are looking to find the area of a triangle, we can set up a matrix so that one of the matrices has a point at 0, 0, and then the other 2 points are organized as a column matrix, and then we are able to use 1/2 the absolute value of the determinant to find the area of that triangle. So again, absolute value this time because area is always positive, so that's why we want to use absolute value to make sure we get that total area. Area is going to be positive, even though we know that determinants may come out to be negative in value. So that's why we want to use the positive only this time. So if we have a triangle given with 1 point at the origin, that's great. If not, you are going to want to make sure that you shift one of the vertices to the origin, and however much you shift to get that vertex at the origin, you will shift the other 2 as well. So we'll look at examples like that. So again, if you have a triangle who has 3 vertices and notice one of them is at the origin, you're going to use the other 2 vertices and we're going to set up our little column matrix. We have 3, 4, and then 5, 1. And then in order to find the area, we're going to take 1/2 the absolute value of that determinant value. So in this case, if we are looking for our determinant, we are going to take A times D minus B times C, so 5 times 4. So we end up with 3 minus 20. Our determinant is negative 17. But again, we are going to want the absolute value of that determinant value. So really we're going to be taking half of 17, which is 8.5. So in this case, 8.5 square units ends up being our final answer. There is one for you to try in number 2. You are going to set up your matrix using the 2 points that are not at 0, 0, and then 1/2 the absolute value of your determinant to get the final solution. Now, what happens if we have a case where this is not at 0, 0? Well, we need to shift our point so that one of these vertices do end up at 0, 0. So I'm going to choose to shift point A to 0, 0. Okay, so now I have my point. So what I had to do in order to get that is I had to add 2 to my x values, subtract 5 from my y values. So I'm going to do those same things to B and C. I'm going to add 2 so that point B is now at 8, 5. And I'm also going to add 2, subtract 5 to point C so that I'm at 1, negative 2. So now that I have my points shifted and one of them is at 0, 0, I can use the other 2, 8, 5, and 1, negative 2. And again, I can find first my determinant value, taking 8 times negative 2 minus 1 times 5. So it's negative 16 minus 5 more. My determinant value is negative 21. Well, again, to find the total area, we're going to take 1/2 the absolute value of that determinant. So again, the absolute value would be the positive version of that. Half of 21 is 10.5 square units. Right, there is one for you to try on the back. Again, it doesn't officially matter which point you move to 0, 0. I usually just like to go with the first one. Make sure you move the other points, and then you will use that to help you find the overall area. All right, for our last example, we are looking to find the area of this pentagon using determinants. So notice this pentagon can be divided up into multiple triangles, and that then can be used to help us find the area. Now notice officially we have different ways we are able to divide this up, right? We could create triangles all over the place. But the most convenient way to divide this up is going to be by using 0, 0 as a vertex for all 3 triangles. Because if we have 0, 0 as a vertex, we won't have to worry about moving our triangles so that it would have a coordinate at 0, 0, it turns into one of those first examples that already has one at 0, 0. So in triangle number 1, we have one vertex at 0, 0. And then in triangle number 1, we have a vertex at -2, 4. And then the other one is at +2, 8. So notice this one was at -2, 4. The way the scale is on this graph is a little funky. So in triangle number 1, again, we're going to start by finding the value of our determinant. -2 times 8 minus 2 times 4. We end up with -16 minus 8. So -24 would be the value of the determinant. Now to find that area, we're going to take 1/2 the absolute value. So in this case, half of +24 would give us 12. And then we're going to kind of repeat that process for now triangle number 2. Triangle number 2 has vertices at 0, 0, and then the other ones would be at 2, 8, and 6, 5. And again, we're going to kick this off. We're going to first look for the value of that determinant. This time, 2 times 5, 8 times d, minus b times c, leaves us with 10 minus 48. So -38 is the determinant. Overall area then, 1/2 the absolute value of that. Absolute value of 38, -38 is +38. Half of 38 is 19. Our last triangle, triangle number 3, has vertices at 0, 0, at 4, 1, and again at 6, 5. So again, we already have one at 0, 0. That's good news. This time when we find the value of our determinant, a times d minus b times c gives us a value of 14. And the absolute value of 14 is 14, right? Because it's already positive this time. So half of 14 is 7. So our last step to find our final area is to take these individual areas of 7, 19, and 12 and add them together to get this total area this time of 38 square units. So a little bit nicer way to find your area, if possible, without having to know kind of the exact formula for that polygon's area. All right, thanks everyone for watching. We'll work more with these in class.